All right, so the main things I want to talk about here when we talk about transforming these graphs is specifically, before we go into those different pieces, is talking about the parent functions. So the three parent functions we've been dealing with have been linear functions. So that would be something like f of x equals x would be the most basic parent function. Okay, it's a line with a slope of 1 crossing at 0, 0. So that's the most basic linear function we have. We also have quadratic. The parent quadratic function is f of x equals x squared. That's what's pictured over here. F of x equals x squared. And then we also have the absolute value function, which would be f of x equals to the absolute value of x. And that's our function that looks like this. Okay, where it's got a slope of positive 1 over here and a slope of negative 1 over here. Vertex is at 0, 0. Again, the vertex here on our quadratic is also at 0, 0. So if we ever talk about the parent function, you need to recognize which one we're talking about here before it gets transformed. So in this example, they're talking about the different transformations. So the key thing to notice, okay, is if we want to identify the parent function here, just kidding, we don't like that example. Moving on. So these are the different ways that we can transform functions, okay? So translations, that's a slide. If it's inside the function, it's going to be a horizontal. So inside the function means it's a horizontal change. So for example, if I have f of x equals x minus 1, okay, that's going to be a horizontal change because it's inside the function, and then the horizontal ones are the ones that are backwards, so this would be a translation to the right. Now again, this is a linear function. If I wanted to see in terms of quadratic, it would look something like this, okay? With that squared there, that's telling me it's linear. We're still moving to the right by 1. Similarly, with the absolute value, it would look something like that. Excuse me. But again, since it's inside what's happening in the function, that means it's a horizontal translation. When it's outside the function, that means it's vertical. And that's the one it fits the way we expect it to. So if I said f of x is equal to x minus 3, that's going to go down 3. Okay, if I say f of x is equal to x squared minus 3, similarly it's going down. But again, notice it's outside the function. It doesn't have, we zoomed in. It doesn't have the parentheses. Okay, so anytime, again, inside the function, it's horizontal. Outside, it's vertical. The horizontal ones are the ones that are backwards. We also have reflections. Reflections over here. Excuse me. So anytime we're multiplying by a negative, so specifically we'll be, I think we're just dealing with these ones, reflecting across the x-axis. Notice it's outside the function. Anytime you're outside the function, it's affecting us vertically. So we're flipping across the x-axis. So that's why the y values are changing from positive to negative. So multiplying by a negative means you're doing a reflection. The last thing we have here is a vertical dilation. Vertical dilation, so this is when we're multiplying by a number. If our number is bigger than 1, we stretch. If our number is in between 0 and 1, we compress. Okay, this is just affecting us vertically. Again, it's outside of the function, so it's affecting slope. Just remember I said f of x equals x has a slope of 1. If I instead have f of x equals 2x, my slope is now 2. If I have f of x equals 1/3 x, my slope is now 1/3. Okay, so it's changing what the slope of the function is. It's a vertical dilation. So keep in mind, we've got all three of these things that could be happening. We've got the horizontal translations, the vertical translations, and the dilations. The only thing that's affecting the horizontal portion is what's inside the parentheses. Everything else is affecting the y values. So let's skip to the next page here and just talk about a couple of these. So let's look here at number 7. So we're multiplying outside the function. Outside the function means it's a dilation. Multiplying means a dilation. 4/3 is bigger than 1, so it is a stretch. Stretch. There we go. This +4 inside, that means it's horizontal. Since it's plus, we got to think about it backwards. It's actually moving to the left 4. And then this -4 outside means it's a vertical. Outside is vertical. And subtracting, so it means we're going down 4, down 4. Here, the first thing I see is this multiplying by a negative. Multiplying by a negative means we have reflection across the x-axis. Because it's outside, it's affecting the y values. This 2 we're multiplying by. Multiplying by 2 means it's a stretch. It's bigger than 1. -2 inside means we're moving to the right. 2 plus 4 on the outside means we're going up 4. Now, if you notice, since we have the squared here, that means it's a quadratic. So what we can tell from this, moving right 2 and up 4 means our vertex is going to be at 2, 4. So keep that in mind as well. You do need to know how to find the vertex of a quadratic function. If not now, then you definitely will on the unit test. So if we want to be able to describe how the graph is being changed, so notice we're multiplying by a negative. That means we're going to reflect across the x-axis. We're multiplying by 4. Means we're going to have a vertical stretch by a factor of 4. -3 inside the function. Means we're going to be moving to the right 3, and +1 outside the function means we're going to be moving up 1. So you should be able to see them. The vertex should be at 3, 1. Vertex is going to be here at 3, 1. And it's going to be opening down with a slope of 4